Okay. Hello, everyone. Welcome to the database fundamental class. Can you hear me? Just one response. Okay.
Yes, we can hear you.
Yeah. Okay. Excellent. So, welcome to the introduction to database technology. And as a first class, probably we'd like to introduce ourselves. Many of you, I really appreciate that many of you participated on the forum. If you can share, I will ask you about your database experience, if you have any, and any expectation from your side, and so on. So as a first class, I'll go through, I added some materials in the PowerPoint slide. So it's a bit of general discussion would like to go through. Now, my name is Dr. Manzoor Ashraf. I put my details in the website. Now, if we look at some of the basic things, I'd like to share the website. Sorry. Okay. I'm not quite sure about two. Okay, so in this screen, if I share that, so in the website, I really appreciate if you could share your introduction. I try to read, I try to respond some of the points from there, but even now, actually, it's time to talk. Basically, if you'd like to. Now, before going there, I think everyone is familiar with how to use the website. So if you look at the introductory page, there is a file in which we can see all the course descriptions and the outlines, and the most important thing is the sessions, the session outlines, right? So for example, on the first session today, we'll go through the introduction, the basic idea on database, then ER and extended ER model, and transformation is really important one, a detailed idea about the ER diagram. And ER diagram is basically the half, or I can say that the major part of database. It requires a lot of solving exercise and go through looking at different scenarios, basically. And then the normalization and data manipulation using relational algebra will start, but this normalization will also help these ER model, right? And then the structured query language, that's the remaining half of database, practice week, and then will followed by PL and SQL. So this is the outline. Many things will be covered in 6 weeks. If we look at the assignments, the next week there will be quiz, 10% marks for the quiz. Week 4 is the assignment for the ER model, ER diagram. Assignment 3 is another quiz, week 5, and then the final assignment. So there are 2 assignments that I need to check, and the 2 other 2s are quiz, so that will be automatically marked, right? So that is the basic kind of structure of this course. Again, if we look at the discussion forum, there actually you can respond to each other. Definitely you're doing it. And you can introduce yourself. But before jumping to the subject, I would like to hear from you. So if you can, I mean, it's up to you. If you want to talk, you can talk. You can raise your hand. I can ask. I mean, that's, I think, the best way to start. We'll spend some time on that. If anyone would like to talk, just raise your hand. I can ask you. What you can talk your name, and your name is already there. If you have any previous database experience, now that database experience may not be 100% database. Probably you worked in another project in which you used database. So I want to hear what sort of technology you used. And I mean, if you don't mention the technology, you can just mention what was that nature of the work, right? So anyone would like to talk? So Roshan. Yeah.
Hi there, I'm Roshan. I have been working as a trainer as well for one of an RTO in Adelaide, and I do work mostly with AWS RDS Relational Database System, mostly the SQL.
Yes.
We use it to manage our student database and manage different workloads.
Excellent. Yep. Good. Um, okay. Anyone else? Okay. So yes, Nathan.
Yeah,
Nathan. Yeah.
I'm going to be one of the more beginner kind of people. I've had 1 week of SQL from the IT fundamentals subject last term. So
Okay.
please be nice to me and anyone else who's also done IT fundamentals, because our knowledge is pretty limited at the moment.
No, that's good. I'll actually focus on the very basic level. I'll try to cover everything and to the advanced as well, but mainly focusing on the basic, assuming that you have, because the fundamental things we need to be made clear. Now, Ron, please.
Hi.
Hi.
I did end user computing as a minor in a commerce degree back in the 1990s, and we had to do a lot of work with DBase, which was the database system way back then. Since then, I've probably used MySQL a little bit in the back end of some websites, and a little bit of Microsoft Access over the years. But in my more recent past 10 years in work, I have little exposure to the back end of things, but occasionally have to write SQL queries to get data out to report on things. But that's about it.
Excellent. That's really, yeah, I really appreciate that. Now, Sandeep.
Hi, everyone. My major exposure to the database is in terms of the front end only, like using the SharePoint, leveraging that system with the MS SQL servers. I haven't written any kind of query, so I'm very looking forward to learn the SQL part, because it's always intriguing to know that where the data is coming from and how it is being handled at the back end. But yeah, other than that, yeah, working with the DGCS and as a finance and business officer.
Excellent.
Yep. Thank you.
Okay, thanks. Ayastum.
I think it's given me my surname in there automatically. It's Mac Lasoda.
Okay.
I've been a PHP and Linux developer in my past life, and I did quite a few applications using MySQL backend. So yeah, I think joins and unions and stuff like that. I'm quite comfortable with hands-on SQL queries. Also done a little bit of DB2, but I've never done any formal training. So actually, when I looked at the ER diagrams, it made my head hurt a little bit, but I'm hoping it'll kind of bring it all together.
Excellent. Yeah. So these are the things, right? I mean, that can actually improve everything. I mean, the optimizations and other stuffs. Rob Lee.
Yeah. Hey, how's it going?
Yeah.
Yeah. So I did a computer science course in the UK in the 90s. There was a database element to that, so I've got a bit of experience, and some of it's coming back to me. I also did Microsoft SQL Server course. It's about a week long, and I've done some Access database development previously, but
Excellent.
yeah, just looking forward to the course.
Really excellent. That's good. Okay, Sandhu, PJ Sandhu.
Okay, thanks. I've just started working as a data analysis. This is my 3rd month on the job. And before that, I didn't have much exposure to data apart from just maintaining spreadsheets and stuff. But now part of the role is to write queries, extract data, and to check how that data is stored.
Excellent.
And yeah, so I produce reports for wider stakeholders, and there could be a request for certain data. Then my job is then to find that data. Yeah, and
Okay.
once I've know more about building database, that'll be part of my job as well.
Okay, fantastic. That's good. Okay, so that will definitely help. Now, David.
Yeah.
Yep.
So I've used to work as a full stack developer, so I've got some experience with SQL databases and NoSQL databases from a web development point of view.
Okay.
Now I work in cybersecurity space, so I'm still involved with databases, but more from the point of assessing data flow and controls around database security.
Excellent. Yep, that's fantastic. Good. Okay, and Anna. Yeah, you're mute. You need to unmute. Yeah.
Yes, I'm a total beginner. I
Okay.
have used a lot of databases because I've been a financial planner for years. What I have found talking to people working in the industry is that a lot of databases are essentially created to solve about 80% of the problems that might arise, and the other 20% are like, oh, that's a nice to have. For some reason, I always seem to find myself in the 20% of cases and very frustrated. So I'm really looking forward to studying this.
Okay, excellent. Yeah, I mean, that's really appreciated. Tahmina, yes.
Hi everyone, I'm just a beginner as well. I don't know much about database. I've just started my course, and for 1 week, I think for IT fundamentals, we just have some knowledge
Excellent.
about database. That's all.
Okay, no, that's really good. Okay, I think there's an ID 1530. Yeah. Yep, please.
Oh, hello, it's Kimberly here. I don't know why my name's not showing. Sorry, I'll have to work that out. Total beginner, but I use databases every day. I predominantly run a hotel, so we have all the database of all the bookings and the guest information and things like that. So I use them for searching information and to use the data, but not so much about how it's all put together. So I've been reading a lot about that so far. So other than that, absolute beginner as well.
Excellent. So really, I mean, you all know that everyone have different type of experiences, but everything should be fine-tuned together if we go through the basic idea on this particular course, the database fundamentals. I mean, in fact, the basic ideas are really important. Now, in terms of goal, of course, our goal is to understand all the basic fundamentals so that in our workplace, we can utilize those concepts, or we can make a career, for example, or do whatever we want to do. Even if someone is really interested on the research side, that is also an option. So all possibilities are there. Of course, it's just 6 weeks, but I looked at the course materials. It's really covering everything. It is really intensive, and every topics are really covered. Now, I think I can start with that, because I put some slides in the middle, and I mean, I definitely want your discussions on that as well. And let's see how we can go. So if we look at a day in our lives, so like Susan's life, for example, I mean, we know that from the wake up till, I mean, when we go to bed, I mean, every time what we do is linked up with a data source, a database, or we're working with the data, right? So for example, in the morning, when Susan goes to the grocery shopping, for example, right? I mean, all the product data is stored and so on. Oh, sorry, my mistake. Thanks for letting me know. Okay, I just shared the screen. Okay, so this one. Okay, so I mean, from the morning, right, and throughout the day, we deal with different types of things, and we know that if we try to think that in every instance, everything is connected to a database, in a backend database. Like for example, for the grocery shopping, like where the product data is stored, right? I mean, does he pay with a credit card, right? All sort of questions. Later, she picks up her prescription at the pharmacy again. That is in another database, right? That is stored and related to all the patient, all the prescriptions, and so on. And when going to some of the, I mean, purchasing some of the items online, then definitely there's another kind of backup stored data in Amazon or other places, eBay or whatever. So the profile, the credit card, everything is saved. Even whatever she did before, what did she purchase before, everything is stored in a database. At night, she plans for a trip, buys airline tickets and hotel reservations. Again, where does this online travel website get airline and hotel data from, right? This is also stored. And before going to bed, she checks her social media accounts. Again, it's a database. Now, one of the idea for different types of applications, the question is what sort of database, data structure is needed in an application? Is it same? Is it different? Why different, right? This is, I think, one of the query we need to think at the very beginning. And that's really, really important. And we'll see in this PowerPoint slide, there are four types of different data models. We'd like to then if we can understand those four types, we can try to fit them into any application. And we need to decide which data model is suitable for my particular scenario. Now, this is an interesting point. This is an interesting point that I said that there are four types of data model, but in the remaining 5 weeks, we never really will go through the three types. We just go through the relational database model. But nowadays, for example, if we have some big project or any project in regards to social media applications, for example, then probably relational data model is not suitable. So this is some of the questions. I mean, it's never ending basically, where the research areas is coming. Now, we go through some of the basics. So again, why should we use a database? So imagine owning a business, for example, right? Say DVD rental agency. What sort of information, that is data, would you like to keep? Okay, just let's say, I mean, one question can I ask? I mean, if you can answer, what is the difference between data and information? Just a basic question, probably. Anyone would like to just can talk? What is the difference between data and information? Anyone?
Any random piece of number or text or anything is data, and when we put together data, and the related data put together is information, which gives us some insight, some value. Once we have that data put together, that becomes information.
Yeah, I'm close to the real thing, right? I mean, it's sometimes hard to tell. Anyone would like to talk about the difference? Okay, I just
so if I have to, so let's say if I have to give an example, if I
please
take an analogy of a car, so if I just look at the wheel is a data, because just wheel itself doesn't make any sense. But if we put different data like wheels, we can have battery and engine and all that stuff put together, then it becomes a car, and that is information. So we can use that information to achieve something.
Okay. So I mean, that explanation, I mean, we need some explanation, right? That is acceptable by everyone, right? I mean, not fully, I mean, clear, of course, it's probably it makes sense to many, but sometimes, you know, is there any technical term for that? How can we differentiate? So some example came in, even you can write in the chat, right? So for example, one of you said that data is linked with some entities. I'm not quite sure what is entity, right? Anyone? So
I'm not
just,
sure if I'm right on this, so sorry to jump in.
Mhm.
Would it be the difference between them that data is collected and stored is something of value, and information is just something surrounding data that it might not
It's
be
again, I mean,
necessary?
that actually I like. I mean, it is close to what I'm trying to think. I mean, yeah, correct. So it is actually explaining something, right? There is a term called meta data, right? Meta data. These are the technical term, but we'll see more example. So I just pause it there. I mean, we'll come to that exact definition after a few slides, but we just focus on here actually, and then I'll come back on that technical term. So what you'd like to keep, for example, for a DVD rental agency nowadays, actually, I'm not sure, no one is doing that unless it is an online thing, right? So current stock, like the titles, manufacturers, right? Customer details, we want to keep current loans, right? Past loans, hold request, by whom and what of, right? Stuff details, suppliers like DVD, snacks, accounts, income, outgoings, overdue, fines. So how would you manage this information, right? Now, even, I mean, at the initial stage of database, what we should focus is to identify these parameters clearly. I mean, identifying these parameters is the first step before the database modeling, right? And that and that will give an idea, technical term. That idea is defined in a technical term that's called entity. We'll come to that point, right? So whatever you know, unique thing we need to try to identify that. That is the first step. And then the question is, how would you manage this information? We can create a database that stores the information and tracks the business transactions. Okay. So why use a data? So you have a database, for example, what questions might you ask the database? Okay, this is an interesting point. So if you look at the previous slide, this is the structure. So this structure is the application or the outcome of this structure is the ER diagram that we'll look at the next class, ER diagram. And if we look at the next portion, that what questions we can ask to a database, these questions and the database software definitely will give the answers. That is the part or outcome of query languages. Like we can ask some query and it will give the answer, right? So that is the second part, right? So if we look at the questions, for example, in this case, how many DVDs are overdue, right? Interesting question that definitely the officers, I mean, the management would like to see. Do we have enough copies of the Hobbits? So we need that question. We need that the answer of this query at any time. I mean, to make a plan, right? In order to give a loan. If someone asks for a loan, we need to have that query. Can we pay the stuff this week, right? Again, the management question, which customers haven't been in for a while and who would send them this special offer? So these questions can be translated into queries that is written in a form that a database system can understand, right? Anyone have any question up to that point? Is it okay? So all good, right?
Yes.
Okay. I then would like to go. So this is an additional slide. So some of the slide probably I just put some additional thing. Well, I mean, it's not that important because it's just the basic ideas even by looking at the video is good enough. So if we look at in front of us, it's a text file. It's a text file. And the question is that, is the text file enough? Is the text file enough to keep record, right, for a database, for example? I mean, it depends on the purpose, right? If the purpose is that, we have only few items to keep record, right? Then probably text file, we can deal with that. We can do that in a text file. We can save everything, because one of the advantage of text file is that it's really easy to edit, right? And easy to add a data, easy to delete a data. How the problem is that if it grows, if we need to increase the number of customers, then definitely it's really difficult to manage. Like in terms of searching, it will take time, and of course it's really difficult to manage, right? And so on. So that is one of the thing, and I can say that depending on how we can organize that thing, it can really help as a beginning database tool, right, in which we can keep record. Just think about a situation like 100 years ago, for example. People used to do the business, but then there was no database software. They probably used to keep record in some form, right? So that's an interesting thing to ponder upon. We are mainly looking for something which is efficient. So of course, if data grows, then without a computer, we can't really do that, right? So that is one thing. Now, the next step from the text file, because there are some difficulties, right, is a simple spreadsheet, for example, right? The Excel spreadsheet, many of us do it. And this is really powerful. A spreadsheet, in the Microsoft Excel or some other, like the OpenOffice has their own, right? So all these have the features to even query. Hello, recording. I think I'm recording it, right? For someone else. Okay. Yeah. So this spreadsheet in which we can do exactly the same thing, but we can easily compare the difference, the advantage between this and that, right? For example, here, we can sort, we can search, whatever we can do in different tabs, right? We can exactly do better things, better than the simple flat or text file, right? We can do better. And if we look at the advantage that it is readily available applications like the Excel spreadsheet, simple to add a record, right? And deletion and as well. Now, easy to do simple calculations. However, an interesting term came here, the difficult to manage the data quality. Okay, so this is one of the things we'll talk about, that the quality. What does it really mean? There are many meanings of that. One of the meaning is that if there is a spelling mistake, for example, like the Joe Citizen, if I would like to put him many times, then if there is a spelling mistake, it will indicate another person, right? Is it okay? Another person. So that is one of the challenge. So what happens if I make a mistake in copying the same people multiple times? That creates some conflict, right? A complicated situation in which a big question will come, and that's called low data quality. So the data quality can degrade. That is one of the thing. And second example is if I delete a data, for example, if I put a null data due to some mistake or due to not getting the data, for example, then that also lowers the data quality of this database. Now, we need some other software, another software in which these problems can be protected, right? That is one of the focus to use another thing, right? So that's why we see that we need something else. And of course, another problem is that it's really difficult to manage when the data grow. When it's a huge data, then we can't really use a spreadsheet, right? We can use a spreadsheet, but there will be, I mean, thousands of challenges in terms of transactions. I mean, we'll see a lot of features. To do that in Excel spreadsheet, we need to have very complicated queries, very complicated Visual Basic or Visual C# code at the back end to manage those things. And in a nutshell, if we try to do that step, we are actually making another database, right, on top of the Excel spreadsheet. So we should definitely look for a software which is essentially doing what we are trying to achieve, right? So that's why we need a database. So why we use a database? That to have a good database, as the business owner, you need to have clear idea about your business, in particular what information that you need to store, right? Or requirements. So one of the thing, why did I talk about spreadsheet and flat file? I mean, that's an interesting idea, is that we'll be learning many things in this particular course, right? Probably we can think that everything we can do in, we have to do using Oracle or, you know, SQL, Microsoft SQL or whatever. However, sometimes if the requirement is really minimum, not that many requirements, then the same principle you can actually apply in a spreadsheet, right? I mean, that's an interesting thing. It completely depends on the context in which you are utilizing your knowledge, or whatever requirement is, or whatever the scenario of your business is. Sandeep, do you want to ask anything?
Thank you, Mansoor. Yeah, I mean, we're talking about over here about a spreadsheet, and before that one we had a simple text file. Yeah. So when you talk about the database, what I am thinking from my perspective is that this is a database as well, isn't it? Maybe it is on a small
That's
scale.
why I discussed them, right? Definitely,
Yeah.
these are also database. Yeah.
Okay. So now when you are talking about why you use a database, so that statement, I thought that they might not be the database, but what I processed it as
probably I just added the additional slides. So
better database or something.
Yeah, correct. Yeah,
okay,
so
sure.
Okay.
Oh, good. Okay, makes sense.
Now, in one of the because I just added those two slides, I mean, just recently, just to get the idea that why are we studying this. So the real term is called actually database management system. Okay, so this is an interesting thing. So if I just add that is the exact thing, management system, or in short, it is called MS. So you're right. So database is actually that I just showed, that anything, right, in which you can put the data. But when I talk about the management system, then it has some additional thing. It has some additional management issue, right, in which we need to make sure that the data quality is not low, behind a particular threshold, right? I mean, we try to manage some sort of quality, that data quality, and probably in that particular management system, and a software, a tool will make sure that the data quality is not very low, for example, right? It will pinpoint. And to that, actually, in the second part of the lecture, we'll try to see that sometimes we want to delete a row from the entry, and probably that management tool system will stop it. It will say that, look, you can't delete that because the same data, same information is saved into another table. Are you following, everyone? So it is somehow protecting the system not to delete. So and that is really important, because by that process the overall data quality is maintained. So if we can think about text file or Excel spreadsheet, we don't have such mechanisms. Now, in Excel spreadsheet, we can actually achieve that. We can put some additional coding. Are you following? We can add some additional coding to do that, to do the same thing. And that is actually kind of overhead, right? You have to write the code, and that's not easy. Even that code may have some bugs, some problems. So how many things you'll be doing? So you are basically managing the normalization, managing the ER diagram that we'll be learning, and you're trying to optimize your ER diagram by using different steps that we'll be learning. And at the same time, you are writing the code to improve the data quality, right? And so on. So if you want to delete, if you want to update a data, then another system will protect that. Are you doing it right way or wrong way or whatever? So some of the examples would be clear from the second half of today's lecture, right? That's why I use the term like management system. So some additional set of programs is managing the data quality inside the database. Any question? Is it okay? Or probably some sort of, I know, a bit of theoretical discussion, but once we look at the examples, it would be hopefully clear, right? Okay, now the information is described by a model, which, as for the queries, should be written in a language the database understands. The stored information should be correct and sensible. Now, I just put that, so I want to look at the structure or no. So this is an interesting thing, that the data and the information, right? Data and the information. So one of the basic thing, I'd like to do one thing here, probably. Let's see if I can insert text box. So just a basic idea. Suppose if I type 25, it's a data, right? But if I put some kind of tag, let's say age, right? Age 25, and then ended by another tag, age. So this is one of my favorite example. I mean, so if we do that, then the overall thing makes sense, isn't it? What do you think? So overall thing makes sense because it indicates an age. So you can see that's just in sentence, right? Sentence, but written in a kind of different notations, right?
What these notations are like in the HTML?
Yes.
Okay.
Okay. So it's not HTML actually. That's an interesting thing. So these notation actually they came up with the first W3C World Wide Web Consortium. First came up with this idea to define. Not actually this is their first idea. I mean they use some notation, and that is actually called XML. I think many of you have heard this name, right? XML. And this XML is a very simple concept, and there can be hierarchies and so on, right? So this is XML is extensible markup language, and you mentioned about HTML, right? Like I just write it HTML. So from the same company, when they did that, because HTML is the language of the website. So when website came up in 90s, then HTML was introduced, right? So HTML concept came with the data. For example, if I type 25, and if I type B for, or okay, make it simple, strong, for example. So it's a strong text, right? Strong text, for example, right? So these strong will do the design, right? So this HTML is not really information. HTML is used for a design purpose, right? I can say that. It's used for the design purpose. That was the basic idea. But later, we try to put information into the data, and that's why this is a concept in XML. So is it clear the difference to everyone?
Yeah, very good.
Okay.
Thank you.
Okay. So one of the another thing is that for the browser, for example, like Chrome or Firefox or any browser, they have that functionality defined inside, right? So whenever they come across these data, they will try to print 25 as a bold, right? As a bold, because that instruction is it's a standard from the W3C, and every browser needs to abide by that kind of rule, right? That is the thing. If can't, then it cannot be right, robust, for example, right? I mean, people who type one thing, the browser can't handle it. And also if browser, now you can imagine that interestingly, a browser can give their own notations, for example, but who will do that, right? So, sorry. So this is one of the thing that we can put the design inside the data, but this is not information. HTML is not information, but in XML we can get that. Okay, now in a next step, that's an interesting thing. I can go more on that, which is
sorry, can I ask
suppose
something?
I just if I put a slide, for example, and I just show you one thing as a first class. I'm just in a relaxed way, I'm just going through a few things. You can also ask anything, or you can also give me feedback, right? If you want to say anything. So I just do one thing because it is related to the database. That's why I would like to, sorry. So for example, if I say that a student, right? And that's a student. That's an interesting thing that I'm just doing right now. So student. So we're trying to put the database of a student using XML, right? And in which I'm just putting ID, for example, and I put some ID, and then I put this stopping tag, right? And then I can put some name and Mr. A and name, right? And then put address and put some data and address, right? And then that's it. So what you can see here is basically a database, like the third example. So we looked at text file, Excel spreadsheet, and this is the second example. And this is very close to what we're basically learning in relational database. So again, I talked about relational, but I didn't define yet. We'll define it soon, but that is one of the way we can really make a database. And interestingly, that this structure is pretty popular even at present in most of the programming language, like for example, ADK, which is the Android Development Kit, to make a native applications for the Android device, for example, in which most of the front-end designs are based on the XML notations, right? So again, coming back here, so I just got a student here, so I just copied and I just paste it again. I just change the IDs, right? Mr. B. So this is the second student. Since I can make third student, right? I can make third student and the address. So the whole thing I can put as another tag, for example, student list, right? And I can make kind of ending. Now, interestingly, if you just copy it and save it as a something.xml and try to open in the browser, you'll find an interesting thing. Okay, so this is an exercise. You can try to see what happens. You'll see that you can fold it. You can really do some sort of interesting thing. Does it make sense, everyone? Any question up to this point?
Oh, sorry, my name is Imad.
Yep.
I think that's my look into this one, that as if that the student is a box and the data inside it, all the data. Is this what you mean?
Yes, correct. So it actually gives a hierarchy, right?
Yeah.
Right? It's a kind of tree structure you can think of, right? Student list is the root in which there are three right?
Yeah.
Second is a three leaf in which there are three components.
I got it. Thank you.
Yes. Okay, excellent. So this, I just gave an idea that
Yes,
in a
excuse
different,
me.
yes, please.
Sorry, can you post some notes or something to us for those who aren't understanding this, just so we can catch up? Because I suspect this is falling in that section too beginner for the people who know something and too advanced for the people who don't know anything. So if you could possibly give us some background for those of us who are beginners, and
No,
then
that's okay.
that would be great.
No, that's really, I really appreciate. So what I did, that's why we're recording the video, right? And in the video, actually, I explained in a different way that, I mean, I just try to define, not the database, I just try to define what is information, right? And what is data. And to differentiate them, I gave this particular example. Is it okay? So please, if you're really beginner, just ask me the questions, right?
I guess
think
the probably the important question, I think where the other person, I didn't catch the name, was probably concerned about, is this something that we, is XML something that we need to know, or is it an example?
No, you don't need to know. These are just extra examples. Is it okay? So you really don't, I'm just giving some examples while adding that thing. Now, the best thing is that if you download the PowerPoint slide from the Moodle, you will not find this information. Is it okay now?
Yep, thank you.
That's fine.
Okay, so these information, like these, even this picture is not there. I tried to explain some of the things that is found in the text. For example, I'll just make it clear. So for example, here, that the word information came, right? And sometimes the word data came. So I just tried to put some additional slide to explain the difference between data and information. And to make the difference, I added some extra coding, like the XML thing, some examples. So I strongly suggest everyone, for the quiz, for example, right? Week 2 is the quiz. Just focus on whatever you find in the Moodle. Whatever you find in the Moodle. Is it okay, everyone? Anyone needs more clarification? I mean, I also need feedback, right? I may be wrong. I mean, just
thank you.
Yeah, excellent. Okay, so these are the additional thing, but please focus on mainly the PowerPoint slide that you can download at your end. And these extra information will be preserved in the video, right? So if you go through, you can get some more information. Suppose if you missed the XML, again, if you look at the if you look at the video from the beginning, you'll find that very slowly I went through the XML when I explained the difference between data and information, right? So I think that is one thing. But I really appreciate that you pointed out that, right? So if you just, if you don't understand, just stop me and ask me a question. I try my best to cover that from the scratch in a very simple manner. And as a first class, actually, I like to give a lot of information in the video, but focus on mainly the content that you find in the Moodle. The question will be based on that, on the Moodle part only. Okay, so I go through, I proceed more on the why use a database. So database usage includes retail information, hospital records. For example, in a hospital, the treatments availability, per patient information, per doctor information, ward and bed availability, billing data, right? Everything we need to store. So of course in today as well, but mainly from next weeks and onwards, I mean, most of our time, we'll spend most of our time on finding out different entities. These are actually different entities. We'll come to that point later on. But what sort of unique information we need to store? That is called requirement analysis. Requirement analysis for the software or requirement analysis for the database that we'd like to explore. That's why the lab works are really important, in which we will go through different scenarios, and from that scenario we would like to identify different entities or parameters that is required to think about a database, right? How we can make a database from those entities. Okay. Mass storage, weather records, like thousands of sites, many observations per day, many values per observation, many years of records, right? For the weather records, we can come across this type of situations, right? Typical situations. Satellite images, again, another type of databases, right? In which we try to store the image database, and sometimes the metadata of the image we would like to store, like information about the image, for example. I mean, you can think of that as a similar type of thing, that an image, you try to define it. What are the different parameters? There is another technical term called JSON, but you don't need to understand right now. These are just different types of, I mean, technical things if you really go for the programming side. And mainly for the, I told at the beginning that there are 4 types of database model. One of them is relational database model. Our complete course, this complete course is based on the relational database. But there are, besides relational database, there are hierarchical model, network model, in which sometimes this XML or JSON, some other terms are really used. Okay, so of course, that's if you can take any advanced level database, or sometimes you can, if you have the basic foundation of the database principles, then you really, I mean, that's my understanding, you really don't need any further. You can do it by yourself, right? Unless you want to do it, that's different thing. But these fundamental ideas we need to have at the very beginning. But as a first class, I'm actually going through everything, just so that we can think about the big picture. The telephone records, like who to whom from, what route, how long, what is the costing, right? Every detailed information we can keep in the record. And the database provide a uniform framework for handling these these very different activities, right? Okay, so what is database? A shared collection of related data designed to meet the information needs of an organization, right? So we went through some examples, and that's good enough, right? A shared collection of related data designed to meet the information needs of an organization. Now, the difference between database and database systems, I already touched on that particular thing. So just need to read that thing. So a database is a representation of some aspect of the real world, or perhaps a collection of data elements or facts representing the real world information. Sorry, just one thing to see. Okay. Yep. Logically coherent and internally consistent, designed, built, and populated with data for a specific purpose. So that is the database. So if we try to comprehend the definition, the text file, Excel spreadsheet, or the XML, right, and the relational table. Some of you definitely looked at the relational table, but we'll see that as well. But at least everyone, I mean, I explained the text file, right? A spreadsheet. I mean, the example was in front of you. All these are database, right? According to this particular definition. But if you look at the database system, a software system for managing the databases, definition and creating population and querying, right? We define the definition and creation of the database, population and querying. So a software, if it is used, right? So these terms are used somewhat interchangeably, so don't get confused. So, but this is the basic kind of difference, right? If any software is used, it is basically, so just imagine without a computer, if you keep record in a paper, on a paper, in a paper, in a, right, in a row and column way, then you are actually maintaining a database, right? So that is the basic definition. So if we look at a file system, for example, that the employee, the personal department has the employee, all the information files. Sales department has the customers file, sales file, and inventory files. And accounting department has the accounts data, right? So these are all separate file systems. So just think about in your computer, all the files are text file or a spreadsheet or whatever it is. They are not kind of connected. They are all separate, but definitely the sales department has all this information, but they just try to organize within themselves in a different way. But how about in a system like all the department can connect to a software, and that software can pull up data from a database, right? In which, depending on the department, depending on the privilege, depending on the excess capabilities. For example, personal department probably can only pull up these two information. This department can pull up these 2 or 3 information. For example, accounting department can pull up every information, right? Depending on that, the same scenario can be implemented, right? But using a DBMS. So the DBMS is actually is working with a data backend database and pulling up the relevant information to the department in which they have the in which actually the department has the access to the corresponding database, right? Depending on what database they have the access, they can look at. Even within a personal department, the people, everyone may have different types of views. For example, in our Moodle, I have a different view than your view, right? So similar thing can also happen. So in that case, the Moodle itself is a kind of a DBMS like that. Okay. So if we, so this is again another kind of added picture. But if we look at this DBMS, it has data storage, data retrieval, administration, reports, queries, data security. You know, all these functionalities are included. Of course, if we don't use a popular DBMS, like if you want to use Excel, for example, then we need to write the scripting code for everything. That's why we don't want to go through that difficult path. We don't want to make the things complicated. So we are looking for a software which is actually DBMS, which has these particular features embedded, and we just focus on the data and what sort of queries we want to execute, right? That is what we would like to focus on. Okay, so any question up to this point? Anyone have any question? I will probably look at explain an example, then I'll give a short break, right? So after an example, actually. So no one have any question? Is it good, or do I need to be slow or slow down, or it's fine?
Dr. Ashraf, can you hear me?
Yes, yes.
Yeah, I'm Eric. I have health background without much IT technical. So bear with me. Like in terms of like SharePoint, where would that sit in this, right? Is it a DBMS? Because like SharePoint list and it's get linked to MS Teams as well.
Yeah, definitely. I mean, okay. So that's an interesting, interesting questions like SharePoint, because I mean, there is some cloud technologies you're talking about, right? So in cloud technologies, it's basically, I would say cloud technology. So in cloud technology, there are 3 types of cloud technologies. Okay, that's I think I'll not waste much more time. There are IaaS, PaaS, and SaaS, like software as an application, platform. So it's a kind of software as an application. So this SharePoint is accessed by everyone, and it has a backend database. Is it okay now? So you're not accessing to the database directly. You are accessing to the front-end application in SharePoint from different defined kind of IP addresses or different computers. You are accessing to the front-end software, and that software is the SharePoint, which in backend is connected to a database. And definitely it is completely well protected. It will never disclose that. Is it okay?
Sorry, can I clarify again? My name is Imad. I think that whenever he's asking, it is not SharePoint. All the data, it will be on OneDrive.
Yep. Yeah, that's fine. It can be. I mean, there are in cloud, actually, there are other different options you can actually make. Any other things to add from anyone? Any feedback or any comment?
It also depends on the policy of that country, that data sovereignty as well.
Yeah.
The policies, I mean, might be the data is of Australia, but it might be sitting in somewhere in Europe as well, depending on like what system we are leveraging. If it is like more of the Microsoft, the US based data, they sit in the US, and the Australian data, it sits in the Europe side, and especially with the SharePoint, some old organization, they used to have like server rooms, like we have one of the server rooms where the data stores, but most of the SharePoint that is leveraging is online database, MS SQL Server.
Okay. Yep. I'm actually I'm expert in AWS. I work in AWS side. So Azure, the Microsoft Azure, I'm not quite familiar with that. But according to the AWS thing, that it's called VPC, and you can make you can keep your data to anywhere in the world. Basically, you can actually define depending on which subnet and which location, geographic location you actually put on. You can put into multiple locations using a load balancer. You can manage. But I think the similar type of thing or kind of variant of that nature is also applicable in other cloud technologies.
The reason
I
was able to
very quickly.
Sorry. The reason I was able to know this because working in the government, the data doesn't need to be can't be go outside the Australia. That's why it has to sit in somewhere in Australia. That's why
that's what you said about
made.
The policy, right?
Yeah,
you defend the policies, definitely. So with the policy, you can actually limit that. That's really quite interesting, and
Like
that's
I
really
just
needed. Yep.
Yeah, I just wanted to add on that, Manjur. Like with AWS, they do have like GovCloud for US, where the government data are protected by GovCloud, and we individuals are not allowed to access those data. Only the US residents who have permissions from AWS are allowed to use it. And they have all the countries, they do have their own policies for data. So, for example, if it's like personal information, I guess it does fall under GDPR, and there's another one for health known as HIPAA Act. They mention that the client, whoever they have, those information needs to reside in that certain country wherever the clients belongs to. So for example, if it's like medical information of people from Australia, the data centers needs to be in Australia. It can't be outside globe. So that's like it comes under the compliance policy and stuff.
So again, I mean, all these are under the umbrella of the policy, right?
Yeah.
So with the policy, we can actually define, and we need to abide by that particular thing. Okay, I coming back to this real example of the database fundamentals. If we look at this example, that is really, we need to focus. I mean, whatever we discussed up to that point is really just the basic. I mean, if you, most of the things are, some of the things are really technical, you can skip that. That's why you download the PowerPoint slide from the Moodle, and then you just read it. I think 1 or 2 read is good enough. But even then, if you're really very beginner, please send me message. I try to, even we have I think a kind of meeting. It's a kind of a student meeting, right, on Monday. So please shoot me an email, then we can discuss more if you have any question, right? It's a one-to-one session type of thing. So that's really good. Okay, now if we look at the database of this example, that is a student, and we see that this is a table of a student, right? And it has 4 attributes like the name, student number, class, and the major. And these are the data, right? And each data is actually called tuple, T-U-P-L-E, tuple, and there are 4 attributes, and there are 2 tuples. And there is another table which is subject. It is a subject, right? And then we see that there are 4 columns: a subject name, subject code, C points, and department. Prerequisite, it has the subject code and the prerequisite code. But interestingly, that they look like kind of same data or similar data, right? So if you look at the 4th table, student result, in which student number, subject code is mentioned, and the grade corresponding. So again, this is an example of the database in which there are 4 tables. One is the student table. It's an independent kind of table, so it should not depend on others. And now subject, again, it's an independent table, right? Prerequisite, it is on the subject code. So there is a link, there's a relation. I mean, there are 2 types of relation. One is that in every table, that every attributes are related to each other, right? And also here, these 4 columns are related. But here, there is a relation between this table and this table by this particular column, subject code, right? And student result is also another table in which we can see that these 2 tables are actually related, all right, and so on. So this is how we can see that we can really put different types of information into a database. But how did we make this table? Definitely, this is the discussion we'll be starting soon, and in depth in the next from the next class, and so on. Okay, so is it okay if I continue few slides more? Is it fine, or do you, because I said that I'll give a break, but if, is it okay if I okay, I can probably, oh, break please. Okay, okay, I would like to give a break, just a kind of 5 minutes break. Is it okay? 5 minutes.
Yes, 5 minutes is great. Thank you.
Yeah. Okay. I'm just starting. So probably this particular part will be finishing. Try to finish very soon. Then probably I'll go through the second slide, which is some technical thing. Now, what are the benefits of a database approach? So the first benefit is to control the data redundancy. So the data redundancy leads to three major problems like duplicate effort, waste of storage, and inconsistency of data. So we'll see some examples in the upcoming slides. However, please note that in relational systems, redundancy will still exist as some fields need to be duplicated to provide the relationships. But such redundancy is controlled and kept to a minimum, right? That is one of the important point. And even for that point, a complete separate topic like normalization is actually proposed, but we'll see that. So if we look at the data redundancy thing here, suppose the student, a number and name, subject code and grade. So definitely if we put that to particular column, then some repetition, it will happen. I mean, if I could keep only the student number against different subject code and the grade, that would be better, right? So even looking at this particular table, we can see that we can at least keep one of that. But then yeah, that's it. So right now we're not focusing on any primary key or anything, but just trying to understand that. Now, if we don't use a database, like put everything in a Excel spreadsheet or anywhere without following any principle, then we cannot really achieve this thing. The duplicate thing would be really common in that particular case. And in case of data redundancy leads to inconsistency. If there are more data, there can be a mistake in the data, and it can then define a different kind of data, right? Not the same thing. That will lead to confusion. Data integrity. So most database applications have certain integrity constraints. So we'll focus more on that very soon. Integrity constraints that must hold for the data. One of the fundamental integrity constraints is that every row should be unique, for example, right? So that is just a very fundamental kind of rules. So all the rules are under these particular constraints. A DBMS provides capabilities for defining and enforcing these constraints. The simplest type of integrity constraint involves specifying a data type for each data item. So these are the benefits. Restricting unauthorized access. Again, I don't need to read, but we can have limited access depending on the logins, for example, depending on the policies, or depending on the passwords or the portion of the data that we want to give access to. We can try to restrict. These benefits are there. Programming advantage is within a database management system. One of the advantage using the programming is that multiple user can have their interfaces to work on it, plus persistent storage. So persistent storage means permanent. So permanent storage for the program. So whenever we do some calculations, that is on the RAM. So that is kind of temporary calculations in the query we'll do, but ultimately it will be committed. It will be permanently saved, the new updated information into the database. For example, if we do a transaction, so the transaction, any transaction is defined as both debit and credit, right? So, and during the, suppose debit operation has been done, but the credit operation has not been executed, then we need to roll it back. We need to go back to the initial step. But once both functions like the debit and credit has been finished, then it will be permanently saved into the database, right? Just a kind of what really happens, I just explained. So that is the benefit and this type of functionality are actually given from the database, right? That is the benefit of using the database. Providing the backup and recovery, another very good advantage that we can have. The backup and recovery thing is in place, right? We can do it manually, we can do it in an automated way, and so on. Okay, Sandeep, do you want to say anything? Just to quickly, you can.
Yes, Manzoor. Sorry, you mentioned that debit and credit thing. So they are two different data, or are they the same data?
Same data. So what I just try to give an example. For example, when the persistent, I mean, how does it work in transaction? Is that a transaction is a complete when, because you transfer some money, right? For example, so it must happen that, you know, from somewhere it will be debited and somewhere it will be credited, right? It's a two entity in a different form. So once both operations has been done, you can say that a transaction has been completed. Make
It is a
sense?
part of one transaction. Both.
Correct.
Yeah.
Correct.
Okay.
One transaction.
So that's
one
why.
transaction.
Yeah.
And every transaction is atomic. Yeah.
Yep. I was more confused about one of the question you asked in the quiz, which says that you can have unrelated data in a database. True or false?
In the quiz, right?
Yeah. So I thought that it is true because.
Okay. Do I need to discuss that here?
No.
No. Okay.
Sure.
I haven't seen that quiz. I haven't seen that quiz. That's okay.
Beautiful.
Okay. Now,
sure. Thank you.
So this is the thing, the advantage. Now, this thing, I really am becoming really quick because I want to jump to the next kind of PowerPoint slide. Another one is pending. Now, there are two parts. DDL is the data definition language. This is focusing on the model, like the ER model and so on. So half of our course is focusing on that DDL, and DML is data manipulating language. So in case of DDL, I just try to make it clear here. So if you look at this kind of picture, that creating a database, alter, drop. So create means creating a new database. Alter means modifying the existing structure of the object or database. Drop, if you want to delete, truncate, if you want to remove. So these are the kind of, you know, creating the structure of a database, for example. That is the DDL part. And DML includes, if you want to retrieve the data from the database, add new record, modify existing record, removes the record. So in a nutshell, DDL focus on defining and altering the structure, and DML focusing on manipulating the data in the database, right? So in our course, we'll do that bit by creating the structure. So in terms of creating the structure, it's not only the coding. So I mean, I would say that 80% or roughly will be focusing more on the ER design. That is completely conceptual, right? You need only your head to, you know, think of what type of, you know, diagram should be there, how these entities are related, and so on. And then some coding. Coding is really minor thing in that case, because if you have the really good design in place, then the coding you can implement that. But to make an optimal design is one of the challenge always, right? That we should focus on. That is part of the DDL, and DML is just the querying. If you have the structure and the data inserted into the physically implemented database, then we can make the queries to get the result, to know the results of different types. Okay, now again, I'll go through really fast. There are 4 types of data model. One is relational DBMS, that is our focus to go through. Network DBMS, network hierarchical object-oriented DBMS, right? So if I so based on the number of users and based on the ways the database is distributed. So based on the number of users, it can be single user, multiple user, based on the ways database is distributed, centralized, distributed, and federated. Okay, so with some extra policies and rules. Now I just show you some of the pictures. Again caution that these are not part of our original kind of PowerPoint slide. It's just for explaining the things. So if you look at the network data model, like all the data are basically, you know, connected to each other in different positions. They are located and so on. They're not in a single table. That is the bottom line, and so on, right? It's a kind of knowledge graph, or some sort of names are really popular. If you Google it, you can find some of the different applications of the network model. And some of the implementations of the network model is telecommunications network, in which the nodes and edges can be represented by switch device, for example. And social networks, even, you know, who is the friend of whom, and so on. You can really connect and represent the data. So right now we are not focusing on implementing how in code we can implement that, but how diagrammatically we can implement the structure. That is our focus. Any question on this? Anyone have any question? Just relevant question or comment you can add. Anyone? Okay, then I can proceed with the hierarchical model. So in the hierarchy, what happened here is that it is exactly, I think, similar to the XML kind of thing. So we see that there's a root in which there are 3 students, right? And each student has a student ID, name, and age, right? And this name is associated with another node. So all these are nodes, but using a tree structure. And each entity has subject code and the name of the subject, Python, right? This is how we structured the whole process. Again, I'm summarizing that there are 3 students. It is the second level. So root is actually the kind of parent in which there are 3 students. It can be more, it can be n number of students. And each student has a next level in which we keep the number of courses. Now, interestingly, according to this kind of diagram, for example, that Muskan, he has only 1 course. He took only 1 course, but this Alex took actually 2 courses, right? And John took only 1, right? So this is how we just structure the database. This is the hierarchical model. Some of the examples, like the file system. In a computer file system, we know that the C drive, it works in this way, right? And we can structurally break down all the ideas. Another example is the XML. I really talked about that at the beginning of the class, about how we can make a tree out of the structure. And this is a database of bookstore, for example, but definitely it is a hierarchical structure, hierarchical model. And the last one is object-oriented data model. So in object-oriented data model, again, it is similar to the hierarchy. However, what happens here is that the top one is somehow associated with the bottom one. So this is the parent, these are the children, and all the properties of the parents can be propagated to the children. So everyone is a person, and every person has certain attributes common to all the children, right? And the person has 3 children, for example, not in a biographical way. So person is a parent, for example, and it is called superclass, and these are the subclasses. So student is a type of person. Okay, this is how we should try to define it. Student is a type of person. So in case of student, it will inherit all these 3 properties here, plus 3 additional property, which are exclusively related to the student, right? For example, student must have a name, student must have an age, student must have a set name, and also student will have a roll number, branch, set marks, for example, right? A function. A doctor must have these 3 things, plus 3 additional things. For example, what is the doctor's ID? Specialist, he's a specialist or not, like a Boolean value, true or false, and something. Okay, I'm not quite sure about that, but some property, for example. about his profession or something. Engineer, what is his ID, in which department he's working, count page, some function relevant to the engineering role, or his position, his workplace, in addition to these three common properties. So this is the superclass, these are the subclasses. So if we can make a database like that, this is an example of object-oriented data model. And if we try to implement that in Java, for example, I just put the code, it's not necessary at all. But just if you're interested, you can have a look. Even you can create that using any AI tool. You can basically create the code, right? So if we just a quick summary of all these three types. So this is the network data model, in which everything is isolated, connected with a node, right? And hierarchical model, in which we can make second level, third level, right? Depending on the context and situation. And good example of hierarchical model is XML that we went through, and object-oriented data model, in which we see that now there is a difference between hierarchical and the object-oriented. That in hierarchical, actually every level is completely independent, separate, right? But in object-oriented, the parent properties are propagated into the children, right? And this is how we try to make own entities and so on, right? That's a completely different discussions. Now, object-oriented and hierarchical and network we don't need. We need this particular model for our course. So just the common term, then I'll finish this particular slide, is that everything we keep in a two-dimensional grid, right? In a two-dimensional grid, we try to put every information in one table, right? And we can have multiple tables. The tables are related to each other, right? This is the kind of summary of the relational model. I'm repeating again that we need to keep tables. To every table is probably, most likely, is an independent concept that is called entity. So every table is an entity. It can be strong entity, it can be a weak entity. That definition will come next class. But in general, if it is independent, this is called a strong entity. So in this particular strong entity, we find there are three attributes, and these are called attributes, which is the column head, and every row. So every kind of attribute value for every person is a atomic value. Atomic value means that the duration, it can have only one value, not more than one value, not multiple value. Only one value can stay, right? And these are called tuples. So tuples are actually rows, and these are called the columns or the attributes, and these are the values. Now, one of the attribute will be simply unique. One of the attribute, now this one is not 100% right. It can be multiple even, right? It can be multiple even, but we really prefer, or most likely, sometimes, I mean, most of the cases, we can get one component which is unique and which is not null, which means that it cannot be empty, plus it must be unique. So this course, I just put the underline by which I mentioned that this is the primary key, and we see that every values are unique. It cannot be repeated here. Then it cannot be primary key. However, the duration, you can see that the repetition is happening, right? As a type, again, same text is appearing, which means that this cannot be the primary key. So this one is the primary key. Any question up to this point for this part 1 of week 1? Anyone have any question or comment? Okay, then I quickly jump to the next one. Sorry. Okay. Okay. So this is the thing. So we already discussed about the data model. There are 4 types of data model, so I don't want to repeat that. Now, the relational data model, that is our focus, that is defined by E.F. Codd in 1970. His definition was on a single table. On a single table, every tuple, within a tuple, all the attribute values or the values of every cell, they are actually related, right? So that's why he used the term relational model, right? That was his definition. Now, there is a picture. Just if you're interested, you can really look at it. It is just the evolution of different popular database softwares, that those are available. For example, if I just zoom in, we can see that it's really bad. Like the Oracle, Informix, all those softwares, SQL Server, everything is actually mentioned, and in which year they made 2nd version, 3rd version, and 4th version. That, if you're interested, you can have a look, and you can see the recent propagation. Now, this chart is really interesting. Sorry. Okay. So this chart is really interesting, in which we can see that which one is the popular. And from this particular thing, Oracle is the most popular, right? The rank 1 sorry, that if we in Google Trend, actually you can find out which one is the recent one. If you get a different value, you can definitely, share with me, or you can post into the forum, right, on that particular thing. But this is the DB rankings that we can find, and these are the popular. And some of you really use, right, MySQL, and I've seen that PHP, Linux, right? Even the DBase, one of you mentioned at the beginning. So these are even AWS, there is RDS. So RDS, relational database structure. So following any of these. So all these are really the popular ones. Now I go to the important bit that is needed. Now, there are 3 aspects of a relational data model. The first one is the data structure, which is the structural part. For example, we talked about attributes, we talked about the tuples, right? And I said that everyone is atomic. I said about that in a table, every cell must have only one value. That is called atomic type, right? Only one. So that one value can be an integer, can be a text, can be a word, can be a float number, or whatever. Data integrity consists of 2 general integrity rules, namely entity integrity and referential integrity. We'll see that example. This is one of the takeaway from this lecture. What is referential integrity means, and what is entity integrity means. One of the entity integrity I already discussed is that the primary key should be unique and not null, by which you can differentiate the rows. So based on the primary key value, you can actually differentiate every rows, right? Otherwise, row can be duplicated, and that is not a valid relational database model. Data manipulation consists of a set of algebraic operators for data manipulations that will be discussed in topic 5, not at the beginning, actually. Okay, so in case of relational model, for example, we want to look at the trams, right? In the tram, like the vehicle, it has number, type, capacity, status, maintenance record, current depot, route number, track, driver details, shift details, and timetable details. So a specific example is here. So these are the vehicle tables. So if you look at here, that there are 3 numbers, 3 tram which has different types, plus seats. How many seats are available? That is stored. That information is in the vehicle table. The route table has the route number, start from where and ends at where, right? Hawthorne and St. Kilda, City to East Barwood, and so on. A driver, his details only, and his rating, right? And the shift. So every driver has the shift on which day and which route and which tram number, right? So this is the database information. Now I really want to see the integrity constraints here very soon. So some of the consistency rules may apply to the real world situation. For example, every vehicle must have a number. Every vehicle must have a number, and it is implicit that the driver names are unique, or the data won't make sense. So now it is implicit, but it's not practical, right? Driver names cannot be unique. I mean, so there must be a driver ID, right? Kind of thing. A tram entry in the shift table should correspond to a row in the vehicle. So this sentence is really one of the main focus of the overall discussion that we'll see, that a tram entry in the shift table should correspond to a row in the vehicle table, which means that in the shift table, if you put a 181, you can't put 181 if there is no 181 here, right? So this is an interesting kind of point, that because this particular attribute number, and there is tram, so it looks like different, but they're not different. Basically, they're same thing. So which means that you cannot put a shift. I mean, just think about logically that I cannot put a shift if the tram is completely not available, right? So if, for example, there is no value like 180, I cannot put 180 here, right? This is kind of violation of rule. So the database will protect it, and that is part of the integrity. Okay, and the next one, suburb entries should be valid suburbs. Again, some check needs to be done by which I cannot put any random name in the suburb. I can make a type the print type mistake and something, so that will protect not to accept that particular value if it is not a valid suburb name. Day entries should be the days of the week. I cannot put anything beyond those 7 days, right? So that can only happen if I make a typing mistake, right? So it should be protected. Okay. So in terms of data structure that we discussed, that something we need to know, that domains, for example, that the possible days are Monday, Tuesday, Wednesday, and so on. So, so any value for the day, if we need to put, we need to take from this set. And for example, the salary, if we put in a database that the salary must be within 0 and 200,000, so that that is part of the rule constraint, or you can say a kind of domain values, that okay, you can only take within this particular range. The relation, we already talked about that. Attributes, tuples.
Sorry. I think one of the, the activity at the back end. So if you go to the above slides where you was mentioning about the tram model.
Yep.
Example.
This one.
Yep. Yeah. The next slide to this one.
Yep.
So you have, I mean, there is a fill in the blank activities. So I was just trying to do it. Suburb entries should be valid fill in the blank suburbs. So I mean, look like it is just written as it is. What should be goes over there? Is that just a mistake that there is a blank?
This one you're saying?
Yeah, you see so this is supposed to be like two different kind
two
of
different
questions.
things. So this is just this kind of examples.
Yep. So suburb entry should be valid.
Suburbs.
There is a blank over there, and then says suburbs. So
no, the entry should be days of the week. So it's just comma. Like this is a concept. This is one fact. This is another fact.
I mean, in the activity, there is a blank before the suburbs, in between the valid and the suburbs.
Seen that. I haven't really seen that. If you could kindly send me that later on in the forum, right, or email me, I can have a look. So here actually this is like different facts. Okay, now so just one of the definition we'd like to go through here. what is basically, so one definition is given about the relation. What is relation? So a subset of the Cartesian product of a list of domains categorized by a name. And a relation is composed of tuples, and these are represented by the rows in a table. And each tuple must have a primary key, which can uniquely identify the tuple, right? So what is this Cartesian product? I just tried to explain that picture. I mean, I just put that just to clarify that. For example, there are three kind of set. Suppose, how can I say? So suppose 3 ABC. ABC means these 3 row, right? 3 row. So whatever value they can have, we need to, I mean, we can technically, it's a kind of mathematical explanation that we can do all sort of permutations of, you know, all possible set. For example, A can have 1 and 2. B, suppose 1 and 2 is the ID. B is the name, which is X and Y, only possible. C is A and B, some sort of value. So if we try to do the Cartesian product, it can give all sort of values, all possible combinations, right? And our table, our relational table is basically not everything it's covering. It's basically covering only 4. Here you can see that 4. So probably only these 1, 2, 3, and 4. Only 4 of the you know, the value we can really put it here to make the relation. So that is, I mean, I try to explain that mathematical explanation just to define this thing, that what is called a subset of the Cartesian product. So the Cartesian product comprises list of all the domains, all possible values, and I just take a subset of that to make a relation. Does it make sense, everyone?
Nope. I found this really hard to understand.
Okay, I'll repeat again. That's fine.
But I came up with a thing that worked for me. It's the valid joining of any attributes across domains. So if
that's okay. That's okay.
That works?
I mean, that works, but I mean, so this term is really what I just explained.
Yeah, that Cartesian, like once you get past 3 dimensions, it does your head in conceptually.
So for example, I mean, it is salary, for example. Suppose the salary field, right? So the salary, I mean, if we define a rule that it cannot be negative, right? So which means it starts from 0 until 100, for example. So there are only 100 values possible. So, you know, so 100 is the domain, right? For this particular value. So all combinations you can take, you know, it's a big kind of list, and we just pick selected to make the subset, right?
Yeah.
Okay. So that's it. Okay. Now, so that's why and the keys. Now, this is an interesting part. Now we are focusing on the probably primary key here. So there must be some way of uniquely identifying each tuple, and that is usually achieved by defining some attribute to be a key or a unique label, right? So in the TRAM database, the root number is the key, right? So if you look at here, so if you try to just understand here that this root number must be unique, right? So that key must be the primary key. That is, in terms of driver, for this particular context, we make it, you know, that unique, but sometimes it cannot be unique. But for this example purpose, we can do that. Now, shift, we'll come to that later. Vehicle, definitely everything is the kind of unique, right? And so on. Now, I just go back. So I skipped that for a purpose, but later I'll try to look at in another example. I just try to make it simple what we just tried to cover. So for example, here in banks, each account number is a key, right? Which is unique, every number. So keys are by definition unique. So no 2 tuples have the same key. More generally, a set of attributes can be a key. For example, this is the first concept. That second concept, that we can have multiple keys together as a key, right? So this is called, for example, the root. So if we just go back to this particular example, I mean, you can really put a combination of primary keys. So who can suggest me that what should be the key here in the shift? Any suggestion?
Root.
Tram number?
But root can be common, right?
Tram number?
Again, they're common, right?
Shift ID. Shift
No,
ID.
there is no such thing, right? Only four data are there. So just focus
Maybe
on this
driver?
particular context.
Maybe
The driver,
driver.
again, Barnard is common, right?
It would have to be a combination of a couple of those items.
Yeah, that I'm saying. I mean,
root tram day.
So in this particular case, even if you take these three, it will end up with common thing, right? So that's probably in this particular case, we can take all four, or we can take that one suggestion came that we can put a shift ID here.
Or a driver ID, like a number at the front.
Not really, because driver can be repeated, right?
Okay.
So shift ID, that's one good solution. Okay, but anyway, I mean, that's we'll look at more later on. Now, in terms of data structure here, so you can see that vehicle number is a kind of primary key. So the tram model can be written as this: route number is a unique key, driver name. Now shift, driver, and the day. So I mean, depending on the context. So if we try to define a fixed day for a driver, I mean, then this combination is becoming a primary key. So the combined driver and day, these two attributes together work as a primary key. And all the primary keys we need to define using the underlying thing, right? And so on. Now, one of the question here is that, I mean, if, for example, the same driver on a day, if you want to drive different tram, that will make it more complicated. Does it make sense?
Is there an easy way to find this kind of primary keys if the data is like for 10,
The
20,000 people?
answer is it only depends on your situation, on your context, right? So for example, in a city, in your situation here, if you find that the driver and day is always fixed, so he's not using another kind of thing, right? It's a fixed kind of unique thing, then this is the valid kind of primary key in this particular context. So in other words, in your situation, you know that a combination of which attributes will always make a unique kind of entries, unique kind of tuples. That is the indication that will decide what should be the primary keys. And now the another point is that you can take all four as a primary key, but you have to ultimately go for the minimal number of primary kind of partial keys as a kind of primary key. So minimum number of keys together, we always try to go for. Okay, just for now, I think that is okay, but we'll look at more examples. Then the same question, that scenario would be clear. Any other question? Any other question? Okay, now this is another example. So just quickly in 10 minutes, less than 10 minutes, I'd like to finish. This is a really, really good example. And if you can understand that, I think this is one of the main takeaway from today's class is this thing is the foreign key concept, foreign key, the referential integrity that we'll see. What is foreign key? Is that by foreign key, we can try to relate to tables, two entities. For example, vehicle is here, shift is here. So this known is the tram number. That is a primary key of the vehicle, but that goes here as a foreign key. And that is how this shift and the vehicle tables are related. They are becoming related to each other, right? So that is how the relation works. Now, we'll see the data integrity, what can happen. One of the fundamental data integrity is that a primary key must, cannot be null, right? Not null. An integer, because it is a particular kind of attribute, is student ID. So if we try to think about the entity and the referential integrity constraints. So these definitions are really, really common. First, we see the entity integrity. So entity integrity constraints means what? No primary key value can be null, and the primary key must not be duplicated, right? So number is always unique, and it cannot be null. So two properties together, it cannot be null, plus it cannot be duplicated. That is called the entity integrity. That's it. Very important question, I think, from this particular lecture. Second one is a referential integrity. This is the last topic, basically. The referential integrity, it says three things. So when I use a foreign key, then there can be three situations. So I just added one slide to explain. So yeah, that should be enough. So one is called restricted, cascade, and nullifies. Now, there are three situations. You can basically apply one of that, whatever your policy includes or dictates, or what is the policy of your organization, what policy all the people in the team can decide on, right? So what is restricted is that the update and delete operation is restricted to the case where there is no such matching reference. This is an interesting thing that, for example, 181. So you see that this is the primary key and this is the foreign key, right? So 181 W66. So we need to focus on only update and delete option, because on that the constraint or the rule is actually acting on, is actually functioning. So if we need to update 181, it is restricted. It can't allow, because that is actually used in another place as a foreign key, right? So any attempt to update or delete, suppose I want to delete 181. So if we have the policy of referential integrity of restricted option, restricted mode, then we can't do it. So if we take this approach, the database will reject our attempt to delete the last row of the vehicle table, since the third row of the shift table refers to this particular value. So if we want to delete 622, this database system will never allow it because the 622 is used in another table as a foreign key. So is it okay, everyone, about the restricted thing that I just mentioned?
Can I ask a question?
Yes, please. Yep.
So if your restrictions change, so for example, tram number 181 is scrapped, do you not need to make sure that's no longer in the database, and therefore you're not assigning drivers to it anymore? So can you change the restrictions as you go?
Now, depending on if you put that restriction, then you can't do that. Does it make sense? So if we put
it
that
doesn't make sense.
Okay, sorry. I just need to mute first. Okay, so Anna, so what I'm saying is that suppose in this DBMS, the restriction is given, right? Is given that you can't do that.
I understand, but if
then,
things change,
however, if you want to pull it off, right, then it is allowed to do. That is actually cascade option that you're talking about. Okay, so different types of options are coming in.
Lovely.
Okay.
Thank you.
Okay. So
Excuse
in cascade.
Excuse me.
Yes.
Does it mean that the user actually defined if it is restricted or cascade or nullifies, or admin will actually define these?
Admin.
Yeah. Okay.
Definitely admin.
All right, thank you.
Yeah.
Thank you.
Okay. In cascade, what happens is that the update and delete operation cascades to this matching reference. So in this case, suppose if you want to change it, automatically it will be propagated to everywhere, right? That Anna is saying, right? So if you want to change, it can be propagated. If we take this policy, what is nullifies? The third option. The foreign key set to null, in which if there is no in all such matching references, if we want to change, right? For example, if we take this approach, the third row, okay, so for example, if we delete 622, for example, what happens here is that this should be then null. because it is not existent here, right? Nullifies. So the value of the tram column of the third row of the shift table will be set to null or meaningless or empty value if we make it changed or deleted, right? So in two conditions, update or change or deletion, then we can actually go through these three policy, and that is part of the referential integrity constraints. So again, I just finished the lecture. So main takeaway is that the entity constraint indicates that the primary key must be not null and must uniquely identify each tuple. And we talked about the primary key can be the minimal number of attribute set by which we can uniquely identify the tuples, and it completely depends on the context in which the situation is, and the situation can completely varies to different places. And the most important part of this particular lecture is these three types of referential integrity constraints. We can take any of these. If we go for the restricted option, then if we want to change any value in the main table, then the foreign key it will be protected because the existence is in the foreign key. We can't allow that. It is not allowed. Cascaded mode, it will be allowed, and nullifies, the foreign key would be set to null if we change the ID or the primary key of the primary key, if we either update or if we delete. Any question? I probably quickly finished the thing. Anyone have any kind of question? So one of the quiz last given here, for example. So for example, if I want to, so look at the lecture, all the lecture ID, and this is the null defined, right? It is null. So what will happen here? So when to cascade, restrict, or nullify? What do you think? Anyone? So this is actually the primary key, and it is null, which means it actually nullifies, right? Somehow it was not there. That's why we put the null here, right? And that means it is actually this particular mode of referential integrity constraint is imposed on the system. Is it okay? Okay, I think I just finished. Thanks for joining today. We went through many things. Again, okay, quickly, one question.
Just to iterate this.
Yep.
So all these three things, which look like more like a policy we are implementing on the data, is depend on what sort of data you have or what sort of department you have. Like they have, I mean, if it is like, let's say a recipe, I mean, going back to the chefing again, recipe never change. They are like mostly coming from the generations. So we might keep it more of the first one, the restricted one, because you can't replace the flour with the maize flour or something. But yeah, if it is like some other, like making a plastic bucket, maybe the plastic, but the kind of the quality of the plastic is changed, and now you are using some other material, and so we might use cascade or nullify.
That's true. Yep. I mean, everyone has, even if you can think wisely, if everyone has some drawbacks and some advantage, pros and cons, everyone has. So I mean, you need to adjust which one is good as a policy for your workplace. Any other question from anyone?
Hi, Dr. Manzoor. I have one question regarding lab. There are 2 or 3 sessions on the lab. I'm just checking, is the same lab, or we just need to choose one, or
choose one. I think I'm not quite sure about that admin side. Probably everyone is assigned in a separate kind of lab, right? Please follow the timetable that you have.
Okay. Yeah, I
Yeah.
think there are 2 or 3 lab sessions. I don't know which one they
Yeah,
assigned
you need
for
to talk to
us.
the
So let's
admin, right?
all these.
That which section you have, right? Or you can talk to the unit coordinator. I'm taking this class for the first time here, right? So I really don't know the admin side much more clear. Anyone have any other?
So sorry, just I missed the beginning of the course. So
Yeah.
Wednesday are the recaps, and then Thursday are the lab session. Is that correct?
Yeah, correct. But this week there will be no labs, right?
Yeah, yeah. And then
From next week.
Thursday, are you doing any of those labs, or is it done?
I'm doing all. Yeah, I'm taking
Oh,
all.
you're doing all. Yeah,
Yeah,
okay.
yeah. And I think on Monday there is a time. It's for if you really are really beginner. Some of you really told me if you need to clarify any context. Of course, this week one is easy, but from next week, then feel free to send me a message, email. I can talk during that time, right? In a very simple way. I try to
Yeah.
make it consistently simple, but you know, that's an opportunity, hopefully. Okay, I think thank you all for attending today, and looking forward for the next class, right? We'll see you next time. Okay, thank you all.
Thank you.
Thanks.
Thank you.
Thanks. Good night.
Thank you.